Hello viewers, you are welcome to Understanding Chemistry by Nkechi. Today's lesson will be looking at how to write electronic configuration of the first transition series. So we start from scandium to zinc. So before I start, let's define a transition element. Transition element is an element which has partially filled d orbital. Okay, so writing electronic configuration, applying Hofbauer's principle will also help us guide us in writing electronic configuration. So 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 3d, 4f. So we're looking at a first transition series. So we might not get up to 5. So of course, you fill it according to lowest energy level. So fill this one first, followed by this 2s, 2p, 3s, 3p, 4s, 3d. So let's get scandium. Scandium is 21. So scandium, titanium, which is 22. So let's start with scandium. So this 1s. After 1s is what? 2s. After 2s is 2p. You can write this in your book because I was looking this thing so that I have a wider space to write. So 2p is 3s. So after 3s, the next is what? 3p. 3p, I have 4s. All right, after 4s, I have 3d. Good. So look at this 4s, 3d. In many textbooks, you see 3d coming before 4s. It's actually so. Why they put it like that? Because they just arrange it in a way that because this 3d, even though yes, 3d is of higher energy level, it's supposed to 4s supposed to come 4s supposed to come before 3d, but because 3s, 3p, 3d they are in the same energy level, that's why it's like that. But if you put it this way, you're still correct. So let's put it the one that's let's arrange it in a way that so this then I'm going to fill it. Scandium is 21. So remember, S can carry maximum of 2 electrons. P can carry maximum of 6 electrons. D can carry maximum of 10 electrons. So start 1s2. We assign 2 here, assign 6. We assign 2, making it 12. We assign 6, making it 18. Then 4s is of lower energy level. We must fill this one that's of lower energy level first before 3d. So assign 2 to s. So making it 20. Then d will have 1. So d will have 1. We can also write it in a condensed form. So since from here to here is argon, this is the configuration of argon. So we'll put argon 3d1 4s2. So this and this are the same. So if your country's examination body, if they accept this one, you make use of it. If they don't accept this one, don't use it. But I know in university they accept this one. So let's do for titanium. Titanium is 22. So the same thing: 1s2, 2s2, 2p6, 3s2. So 3p, 3d, 4s. So I'm going to assign 2 here, 6. That is 10. 2 here, that's 12. So I put 6. That's 18. Plus 2, that is 20. So the remaining 2 will go for 3d, making it 22. So if I put in a condensed, for it to have a 3d2, 4s2. So scandium, titanium. Next one is vanadium. V, the atomic number 23. So do the same. So 1s, 2s, 2p, 3s, 3p, 3d, 4s. So for that to be 23, so assign 2 for s, 6 for p, 2 for s, 6 for p, 2 for s. So from here to here is 18, 20. So the remaining 3 we go for what? For 3d. You know that there's a special stability associated with 3d5 and 3d10. So when they are half filled and when they are fully filled, confer stability on that element. So half filled and fully d orbital has what is very stable. It's very stable. So it will be wrong for students to not to assign any electron on 4s orbital and put 5 because you want this element to be stable. No. So this thing is wrong for student to draw this thing because 4s must be filled before this. S must have something. If it means assigning 1, it's only in that case that if you put 1, if you put 1 electron, shorten the electron from s, from 4s, and assign it to 1, and I give the other one to d. So on that note, that you can say, okay, that will not give 4s completely to a 2 electron. It's only on that note for stability, but not giving it anything at all. It will not work. So this one is wrong for you to draw this thing because you're looking for stability for the elements. No. So this 4s2 and 3d3. So since assigning this thing 1 and this one 4 will not make this element to be stable. Just leave it like that. So the condensed formula will be scandium, titanium, vanadium, chromium. Chromium is 24. So we'll start again. 1s, 2s, 2p, 3s, 3p, 3d, and 4s. So assign 2 for s, 2 for s, 6 for p, 2 here, 6 here. So I've gotten 18. So if I put t here, that's 20. And I put 4 here, that is what? 24. So look at this interior configuration. Another person can also draw like this. 1, 4. Like I told you that there's a stability associated when the 3D is 5 and that's half filled, and when it's what? Completely filled, that's been 10. Okay. So if I remove, like I said, it is wrong for you not to assign anything on 4s or 4s and put everything here. It is wrong. But in this case, because only 1 electron, this chromium needs to be completely to be half filled, only just 1 electron. So in this case, you shorten the 1 for 1s, so assign 4s1 and 3d5. So between this and this one is more stable than this. So a typical calculation for chromium is 3d5 4s1 to be like this. A typical configuration 3d5 4s1 is 25. So we do the same: 1s, 2s, 2p, 3s, 3p, 3d, 4s. So assign 2 here, 2, 6, 2, 6. Okay. So if I put 2 here, it becomes, that's 20 plus 5 here, 25. So you cannot shorten 1 here and put 3d6. It's only when adding 1 can make that element to complete 5 to be 5, or adding 1 will make it to the 10. So on that note, you can assign S 1 instead of 2. So the next one is iron. Iron is 26. Iron is cobalt. So cobalt is 26, 27. Cobalt 27. So 4S2. So make it 20. That I times 7 here. That's 27. 2. So here is 2 and 20. So I'll add 8 here. Like I said, it will be wrong for you to not assign anything here at all and I put 10. No. Something must be on 4S. So the next transition element is copper. So copper is 29. 4S. So if I assign 2 here, 2, 6, 2, 6. So if I put 2 here, make it 20. So this one will remain what? Because 9. So look at this case. This one just need 1 to attain stability. Just 1. So in that case, I will assign this one 1 and give this one 10. So this one is more stable than 3D9 4S2 plus 10. So this is a configuration for first transition series, starting from scandium to zinc. So you can make use either this or this. You can use it. So let's look at how to write a configuration of a transition element if when they lose the electron. So let's look at that. So look at this ion and cobalt. If you have to write a configuration of ion, for example, ion 2, have ion 2, ion 3, for example. So what it means that ion has lost 2 electrons. So what it means, if an element loses the electron, transition element loses the electron, it's going to first of all lose the electron from the 4s. That is lower energy level. It's going to lose electron from the 4s first. So don't make mistake, you're shortening from the 3D. You get it wrong. Or they just do 2 minus 26, 24. Then I draw for 24. They do the configuration of the one of 24. Thereby including 4s in it. So we have 3 F3. This is F3 plus. So you're going to lose 2 electrons from 4s. You're going to lose 2 from here and 1 from 3D, making it 3. So the correct configuration for ion 3 ion is 3D5. That's all. So the mistake that students make, they will do 26 minus 3. That is 23. They will now include, they will draw for this and put like this 4s2 and 3d3, which is wrong. So if you do like this, it is wrong. So if you have to draw for this thing, it means that it's going to lose 2 from this 4s and 1 from the 3d, which originally 6. So it's now the 3d5. So always take note of that. Very, very important. So quick one for the second question, copper 2 ion. Remember, the copper atom is 3d10 and 4s1. So you're going to lose that 1 from 4s1. So this is the configuration for copper 2 ion. So third question, manganese 2 ion. Manganese 25. So we're going to lose 2 from the 4s. So manganese, you have manganese to be 3D. Manganese atom, you have so you're going to lose 2 4s electron. So this is the configuration for manganese 2 ion. This is a neutral scandium atom. This is a neutral scandium atom. So it's going to lose 2 from 4s and 1 from 3d1. So it means that for scandium ion, scandium 3 ion, what it means, there's no 3d, there's no 4s. So this scandium ion, there's no configuration for it. So we'll come to the end of today's lesson. I'll be leaving a practice question for you to answer. So when you do it, post your answer in the comment section. Ion forms 2 ions, have ion 2 ion, and ion 3 ions. So the question is, which is more stable and why? So post your answer in the comment section. Thank you for watching. Do have a great day. Bye.